Okay, see.
Okay. Thank you. If you
Just for
want,
your information, everyone, I met
okay.
Roberto when I was in Barcelona, in Universidad Autónoma de Barcelona. Hace mucho tiempo, ¿no, Roberto?
Yes. Yeah, yes.
10
5,
años?
7.
More?
No, 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 not too much. Not too much. I think in 2013 or
13,
14
yeah.
was the, or let me, because I defend my thesis on September 14, 2014.
Yeah. I came back 2013, yeah. I came back
Okay.
to Malaysia 2013. Yeah, we went.
Have you been in touch with some people in Barcelona?
Yeah, with Esther,
Really?
Jordi. Yeah, I invited them for my class as well. Jordi, and the one in London, Eva.
Eva.
Yeah,
Okay.
Eva. So yeah, and you,
Okay.
of course.
Yes, I've been in touch with Xavier,
Xavier,
and
yeah.
some people they have been here in Costa Rica, but in a seminar 2 years ago, and also Xavier last year gave us a conference for yes, but it was
It's good.
I used to sightseeing.
Right, really miss Barcelona.
Okay, I will try to go, but I don't have enough time sometime. And
Yeah.
also, I don't know, after pandemia, it is not easy to travel because some meetings are virtual or something like that. But I don't know. But I am happy working with you, and also for next year we can talk really.
Yeah, sure. Can I just introduce a little bit about my class?
Okay.
And I'm going to use Spanish, so the student can also learn something.
Okay.
Bienvenidos a mi clase de Ecología Industrial. Es un curso electivo para agregar valor a su curso básico. Están haciendo la licenciatura en Salud y Seguridad Ambiental. Are you familiar with that? Bachelor in Environmental Health and Safety. And hay 40 estudiantes en esta clase, 40 students.
Okay.
Ahora están en sus ciudades de origen con sus familias para la celebración del Eid. So they are all in their hometowns now. Everybody at home. I'm also at home now because we are working from home this week. So we are really happy to have you here, Roberto, with us.
Okay.
And thank you for accepting my invitation for the second time. And it's really good to be working with you. We have good past experience in Barcelona, so it's good to continue working together and for the benefit of the students. And I just want them to know that we are doing this globally. Okay, whatever we are doing, we are doing this globally. So the students also know that we have a research group in Barcelona doing this, and now everybody is back home doing all different kind of things. But still, the core, the foundation is there. So I'm so happy to have you here, Roberto. So the student, can we hear a little bit of your voice? Hola or hi to Roberto.
Sí, así.
Hi,
Roberto.
Hello, sir.
Nice to meet you. Yeah.
Nice to meet you.
Okay. All of you are from.
Nice to meet you, Roberto.
Nice to meet you, Rasik. Yeah.
Yeah.
It's okay.
They're all over from Malaysia.
Okay. Well, from Malaysia and from the master program.
From it's a bachelor program, licenciatura.
Licenciatura, sí. Yeah. Okay.
See, so their bachelor program, and this is their third year.
Okay.
Yeah,
okay.
So they have one more year.
What is the name of the course?
Bachelor in Environmental Health and Safety.
Okay. Very nice. Yeah.
Environmental and Safety.
Very interesting. Okay.
Yeah.
If you want, we can. If you want, we can start right now. If you want.
Yeah, sure. You can try with your slide. I'll stop presenting.
Okay. First of all, again, thank you for inviting me. I am very glad working with you. You are lovely people, and also I had things to talk about LCA, industrial ecology, and one example. I have 3 presentations. I think it could be as quickly as I can, and also be patient with my English because I am trying to speak as well as I can. It's not easy for me because Spanish is Spanish here in Costa Rica. What else? I think, Farah, you indicate me when you want to do a break, 5 minutes. I think in 1 hour it could be good. How many times that I have to talk?
You have 2 hours, 2 horas.
Okay.
Yeah, so we can break at 1.
Okay.
1 hour.
Okay. Okay, I'm going to start right now. As I told you, I am going to present 3 things. One is what is industrial ecology. It's very important to understand. And also LCA. And the third one is about one LCA example that I published. Yes, Lorena, ¿no quiere conectarse? ¿No se va a conectar en la presentación? It's my wife. She is asking me.
Hola.
Yeah. Okay. But she's.
You have your slide, Roberto?
She said that she doesn't understand about these subjects. Okay. I'm going to start with the first presentation because it's very interesting and very important to understand. I am going to give this material for you and for Farah if she want to. I will do a quiz after the class. That's okay. It's a quiz, of course. No. I am kidding. No. I am not going to do a quiz now. It's okay. So I'm going to present my first presentation. Okay, let's see. Okay, compartir. Okay. Did you see my? What are you seeing right now?
Yes, we see.
That's okay.
Yeah.
Industrial ecology, a new discipline.
Yeah. Good.
Okay. I'm going to start right now. It's very interesting why we are going to talk about industrial ecology as a new discipline, because it's very important to understand because the LCA emerged from this interesting discipline. The first, I'm going to talk very quickly about some historical issues, definitions, and trends. We have to remember first the Stockholm Sweden summit in 1922. One of the main findings of this summit was the natural ecosystem acted in favor of the economic ecosystem. So this situation provoked or caused a serious problem because a strong economic growth from nature we observed in the past years. So, but the 2 main problems that appeared on that time was excessive extraction, energy and resources over the natural biocapacity. This is called the ecological footprint that right now is very high around the world, not only in Malaysia and Costa Rica, but also in the United States, many countries, that we are extracting a lot of material and energy to use in the anthropogenic actions or anthropogenic in order to produce the resources or the product that we use to consume in our houses, in our industries, and every activity that we develop in our houses, etc. And also another big issue is emissions and impacts to environment that are causing several problems right now, such as the climate change, eutrophication, acidification, and some others that we can learn how to calculate or how to quantify in order to mitigate some effects over the environment. So this affect and compromise the 2 main problems affect and compromise the life of the living beings for the current and future generation. This is one of the main aspects according with the sustainable development. If you have any question, write on your paper on your computer, and you can send me after my presentation. Oh, let's see what's happening here. Okay. Okay, this situation, as I try to communicate you, is that the situation fell as asleep until the 90s decade, past century. But irreversible impact for humanity appear over the world. As I told you, climate change produced by the burn of fossil fuels and some other anthropogenic activities. So society react a little bit late and so quickly with these impacts and with extractions, uh, try to mitigate and to adapt to the new situation that happened around the world. For example, Sustainable Development Declaration in 1988, Rio 92 in Brazil, the Second World Summit, Kyoto Protocol in anthropogenic in 19 Kyoto Protocol tried to limit the emission of CO2 to the environment or to the atmosphere. It was in 1997, and several summits in the current 2021 century has made a lot of try to make conscious over the society in order to limit it, the use of fossil fuels and some other emission impacts over the environment that are causing several problems for health, for the in general, for the poor people and some risk regions around the world. Uh, with this situation, new disciplines arise in the 90s, especially industrial ecology that appear in the science in the 1990s to now, last decade, and also circular economy that appear over the science and over the organizations in order to reduce the extraction of materials and try to keep the material around the economic systems circulating to avoid extraction and emission over the environment. Industrial ecology is a new discipline that materializes sustainable development. Industrial ecology emerges to measure the sustainable development and also study the flow of materials, energy, and water in an industrial ecosystem. Any industrial ecosystem is any organizations such as schools, factories, cities, um, municipals, where living and non-living elements share its activities. So we have a strong relationship between non-living elements and its activities. Industrial ecology try to imitate the natural ecosystem in order to reach or to get the thermodynamic equilibrium in order to be sustainable. So we try to imitate the use of energy and elements in an industrial ecosystem. I think it's a very clear concept that we need to have in mind in order to understand what is life cycle assessment and the philosophy that is around this interesting discipline. Several strategies and methodologies were born in industrial ecology to study the industrial ecosystems. For example, material flow analysis, energy flow analysis, life cycle assessment, input and output LCA, city metabolism, and industrial symbiosis, between others. But we are focused right now on life cycle assessment in order to identify and quantify the environmental impacts throughout the life cycle of a product system. So we will understand what is life cycle assessment in some minutes because this is a powerful tool in order to understand what is the impact of our activities that cause several problems to the environment, as I will see in some minutes. Here you will find, I'm not going to read all the definitions, but it will be for you in order try to meditate to understand what is industrial ecology according with tips and Ehrenfeld, Lowe, Frosch, Ruth Connolly, and Kosland, and Gradel and Alibi. This is, I think, one of the main scientifics that have been working in industrial ecology and related subjects. My key presentation is this, that, sorry, just a minute, please. Okay. Okay. This is the industrial ecology and life cycle assessment. It's important to understand that the same material that I am teaching right now on this lecture is the same material that I teach at the City University of New York, University of Costa Rica, and the École des Mines d'Alès in France and some other countries around the world, where I teach the class of life cycle assessment. Right now, I am teaching the course of environmental engineering and also ecological footprint, but I teach also economics, environmental economics, and ecological economics that are very related. All the subjects are under the umbrella of environmental science and sustainable development. So one of the things that I'm going to present you right now is environmental situation. What is the background? What is the what's happening around the world? Some definitions, phases, relevance, and a case study that is the second part of this main presentation. As I explained you when I explained the intro, what is industrial ecology, the world has two main issues right now: extraction from the nature of raw materials and energy over its biocapacity, over exploitation of resources. Example, mineral depletion is one of the main impacts, and also we have some material at phosphorus that are depleting right now because we see the world as a stock. So if we extract so much material from the environment or from the nature, in the time, in some years, we will have problems in order to replace the material that we are extracting in some huge quantities. So we have to look for solutions. This is one important thing that we are working right now in the circular economy thinking in order to avoid destruction. So how can we do that? By valorization and treatment of the waste that we produce into the systems in order to have the material around the economical systems circulating in order to avoid destruction. And also, another key issue is emissions, the impacts to air, soil, and water during the whole cycle of a product or system. For example, several damage to the environment as climate change. As you see, I think the picture is very clear in order to understand what is the problem that we are facing right now. To mitigate the environmental problems, several disciplines and strategies have emerged in the last decades. For example, we have industrial ecology, bioeconomy, environmental engineering, circular economy, and some strategies that we are trying to implement today in the industry, mainly on the industrial ecosystem. I think industrial ecosystem is a better representation of the whole organization that are using resources, material. For example, a bank, a factory, municipal, a city, a house. We can englobe any ecosystem with industrial ecology. With industrial ecosystems. So some strategies that we can use in order to born in these disciplines are, for example, clean production, material flow analysis, life cycle assessment, circular process, symbiosis, etc. But now, as I told you, we're going to focus on life cycle assessment. That is the key strategy that was born in the industrial ecology, and we're using this strategy around the world in many countries. I think in Malaysia too, but in Latin America is is a very useful tool in Chile, Peru, United States, Mexico, etc. This is a scheme where that we can understand what is LCA of approach. We study the natural good from extraction. Uh, let's see, we have in the natural good, water, energy, and materials, and we can see here the whole cycle of the material, the from extraction, transformation, transportation, production, distribution, use, and final disposal. So on that activities, we have waste, emission, byproducts, and this is a focus from cradle to grave, okay, from extraction to the grave, where is the landfill, where we put the waste that is not the best solution in order to treat materials. We need to have in mind the circular economy philosophy in order to treat and to valorize and to treat the waste in order to introduce into the ecosystem. But we are going to study right now how to calculate the emissions that are around each stage or each phase of this life cycle. What is an LCA? As I write here, this is one note that I wrote in a paper. Life cycle is a tool born from industrial ecology to calculate the impacts related to a product system, from material extraction to final disposal. LCA imitates the closed cycles of energy and materials found in natural ecosystems. LCA not only closes the cycle but also seeks mitigation and adaptation measures of the impact of the environment on the environment. This is a definition on what is an LCA. Why an LCA? Why is important an LCA? It's important to identify opportunities to improve environmental performance, to mitigate environmental impacts, to inform decision makers, process and marketing, and to select relevant indicators of environmental performance. Remember that industrial ecology is a new discipline in order to reach or to get the sustainable development. So it's very important to understand that LCA is a sustainable tool in order to understand what happened around the system product, from extracting the material, passing through all the stages of the life cycle in order to understand what are the emissions and we can do with that kind of emissions. In my own words, life cycle assessment is the compilation and evaluation of inputs, outputs, and potential environmental impacts of a product system throughout its life cycle. So, and in this drawing, we can see the inputs, raw materials, energy, water. So, when into the system, we have emissions to air, to water and soil, and the outputs that are useful for the people and society are products and byproducts. What life cycle assessment is used for? To calculate impact of a product over its life cycle, to compare the environmental performance of a product or service. We can compare two technologies. We can compare two products. We can compare one desk computer versus one laptop, which causes causes more impacts over the environment. And also, we can identify improvement optimization options in the product system, hotspots to analysis, prospective scenarios analysis in product system, follow product displacement, decision support at different levels, consumer, policymaker, etc. So this is a huge, big definition of, according with the CETAC in Brussels, this definition appeared in the science, I think, in 1995, last century. So, but right now, I think it's the same thing that as I explained you, the life cycle is a process to evaluate the environmental burdens associated with a product, process, or activity by identifying and quantifying energy and material use and waste relates to the environment, etc. And also we have a short definition that give us the ISO 14040 synthesis, production, use, distribution and use, and then the valorization and treatment of the waste that are produced into the system. It's interesting to understand that the first LCA was developed in the 1960s in the United States. Coca-Cola Company developed the first LCA in 1969 and takes strength from Rio 92 World Summit in the middle of the on the 90s decade of the last century, about the consume or use the roof sheets in our houses. We have the end of the product after its life cycle, after its life, the use after its life, and then we can disposal or use. In the new thinking is to recycle, to reintroduce into the system according to circular economy thinking. So we have here relationship between the different stages that we have into the for the iron to produce roof sheets. Okay, and we can see that energy, water, or resources are needed in order to produce the roof sheets. But it's interesting that in all stages or in all phases of the life cycle, we have emission to air, water, and soil. This is another example of a life cycle for wheat products. You can see here all the stages that pass from wheat to produce the bread that we used to eat in the morning, in the breakfast, or during the or meals in general, and then how the waste is transported to the landfill, and also we can see if there are any treatment that is not reflected on this drawing. But you can see raw material, manufacture, distribution, consumer use, and disposal or recycling. According with the ISO 14044, we have four main phases of the LCA. Is an interactive model that it includes four steps: goal and scope definition, inventory analysis, impact assessment, and interpretation. This is an interactive model because in all phases we have an interpretation, and all stages or phases are interrelated in order to have the knowledge of all a life cycle. In this case, we can see that as we call the extraction and upstream production to the door of the manufacturer, we call that upstream. Then we have the core when we produce the products, and then we have the transport, the use. After the door of the manufacturer, we call these phases we call these phases as downstream. Let's see. When we extract the material on the mills, on the agricultural farm, when we transport to the door of the factory, it is called upstream. And then we produce, and after the door of the factory, we call that activities or phases, distribution, use, and final disposal, we call that downstream. Let's see, again, this is the phases or the element of LCA procedure, and then we have the stages. There are two different things, but they are very interrelated. In this case, the phases are they are the phases. Those are the phases that we have to develop in order to have an LCA. And this is the stages that are very related with the phases in order to have the impacts over the activities that we develop on the life cycle. Again, this is the phases, LCA phases, goal and scope, life cycle inventory, life cycle impact assessment, and interpretation. A little bit definition of some of the main key aspects of the phases of an LCA. For example, the goal, we have to write what is the application of the product that we are going to do, the life cycle assessment. For example, a technology, a new product, an improvement that we are thinking to do according with eco design. What is the motives? What is the aim of what is my goal? Why and how we are going to do that? What is my public? What is the organization or company that are going to use the information of the LCA? And then we have the scope definition that have the function and functional unit that we are going to explain later. We have the system boundaries, the quality of data, and critical revision. That are one of the main phases that are related with the scope. And also, we need to know what is the time horizon, or what is the time for the life cycle assessment, what is the main assumptions, and things like that that are related to the scope. When we define the goal and the scope, it is important to understand what is the inventory. Inventory is the energy and material consumption over the whole life cycle. For example, what is the energy and materials consumed and water in the extraction phase, in the production phase, and when we use the product and consume the product, we have to maintain the product, to keep the product into the system. So what we have to do in order to have the product into the system. And also it's important to understand the data and calculation procedures. Two main issues that are very important in the inventory are the allocation procedures and mass and energy balance. So as you see, the LCA is a scientific, and then we have a wall. We conduct the study, for example, for a bottle of 2.5 liters filled with water to evaluate the environmental impact within the production plant of a 2.5 liter bottle filled with water to reduce energy, materials, and water use. We did this life cycle for a company here in Costa Rica that bottle water in bottles, that produce water in bottles for the Costa Rica and United States market. So it's very important that this is a real case. Just a minute, please. And then we have another goal is to identify the product performance to improve the production process and quantity hotspots. The functional unit of a product, in this case, the function of the product or service. For example, the LCA for a bottle of water, the main function of the water is to hydrate a person during a work day or during physical activity. Example of LCA for waste treatment is another case that we work here in Costa Rica to avoid illness to people and to reduce impacts to the environment from organic matter decomposition that produce several impacts over the environment, such as acidification, eutrophication, ecotoxicity, and some other important impacts that that is a risk for the people that live around the landfill or in the houses or in the city and so on. This is a typical problem for all countries. And then, as a functional unit, for example, for the water bottle, we have a bottle of 2.5 liters produced at plant in Costa Rica, a ton of unsorted municipal solid waste. It's very important to understand what is the functional unit, because right now, if you don't have a clear functional unit, you cannot drive in a good way the LCA, because the functional unit is the reference unit where which you are going to let's see to quantify all use of elements around the life cycle or the inventory. For example, a ton of unsorted municipal solid waste, you are going to use this unit in order to calculate the energy use for a ton of unsorted municipal solid waste. What is the water use for unsorted municipal solid waste? What are the cars, the trucks that you are going to use for a ton of municipal solid waste? It's very important because you are going to inform the results according with 1/3 on unsorted municipal solid waste. What is, for example, the emissions of the landfill regarding what refers to one sorted, a ton of unsorted municipal solid waste. It's very important, the functional unit. And then in the functional unit, we have several functional units as unit reference. So all input and output are referred to as functional unit. In this case, the most common functional unit that we use right now is mass, for example, kilograms for pounds, etc. But we can use economics, energy, nutritional content, etc. It's very important the scope to understand what are the system boundaries. The system boundaries is a set of criteria specifying what unit processes are part of a product system. Let me explain you something. If you have a company, if you are going to study, for example, the production of one bottle of water, and you are going to include the plastic, you are going to consider the extraction of the petroleum, yeah, on the cave. Yeah? So, what is that extraction? From extraction to the door of the factory to produce the plastic, the PET or any kind of material, plastic material, in order to produce the bottle. So what things are you going to include into the system, in your system? It's important also to select the stages of a system to be included. Let's see. For example, in this case, what do we take into consideration? What we need to take into consideration into the product system? Let's see. In this case, for example, this is the cradle to grave, from the extraction of raw material to end of use, disposal, or recycling. This is The grave is to disposal, to landfill. And then, for example, we can have cradle to grave, from extraction to manufacturing, the door of manufacturing. Or we can study a gate to gate. And also we can have cradle to cradle. This is the economy, the circular economy thinking that I am explaining right now. So, but it's important to understand what is my consideration, what are my system boundaries in order to study the system. What is the main consideration to take? What is the main issue to take into consideration to select the system boundaries? It depends on the time, the interest of the people that ask for the study. It depends on the economics, because if you include, for example, cradle to cradle is too expensive, because we have to understand and to study all the impacts in all stages that we are studying right now. And so we need more time, more people, more resources in order to do the LCA. Let's see another example. For the bottle filled with water, we are going to include into the gate to gate also the unit process 1, plastic bottle production, blowing, unit process 2, filling bottle with water, and the unit process 3, packaging. In this case, we have unit flows, energy, water, and materials into the gate to gate system. So you understand there are two main let's see, phases. In this case, we have first, we decide gate to gate. We have here the plastic, and then we introduce into the system, the product system, and we have 3 units in order to have the bottled water filled, and also filled with water. And also we have the unit process 3 packaging. If we study, this is the core of the system. If we study on the left part of the gate, for example, extraction the petroleum to produce the plastic bottle, this is called upstream, and then distribution and use or consumption, and then landfill or recycling of the plastic bottle after use, we can call that downstream stages. This is a taxonomy of system boundaries. For example, this is a cradle to cradle, this is a cradle to grave. Very interesting. What means this? What means this? After we produce in the grade, we select the waste or the materials and try to introduce into the different phases of the economy or the system product or whatever you want. But it's important to take the waste from the different stages to introduce into the system. And then we have here cradle to grave. This is the landfill, for example. This is the cradle to gate. Let's see. Extraction to gate. This is my boundaries. And then this is gate to gate, as I explained you before. And this is, this is gate to grave, for example. If the bottled water that we study, we have here the production, we study the distribution and use, and then we send it to landfill without reintroducing to the system. This is gate to grave. This is a case that this is a research that we did in Barcelona when I was there for my thesis. In this case, we produce from leftover of fruit and vegetables. We produce compost, home compost, and we apply this in the field, in the farm, to produce cauliflowers, and then we use here open field crops. We need machinery. The main issue of this paper was to understand the impact produced by experimental emissions of ammoniac, in this case NH3, CH4, methane, oxide of nitrous, dioxide of nitrogen, and volatile organic compounds. And then we hear after we eat the cauliflowers, the waste of the cauliflowers after production and consumption, we introduce to the composter. This is very important because this is the life cycle thinking and circular economy in order to introduce the waste into the system again. This is a closed loop where we are cycling around the system in order to avoid the waste to landfill. Another things that are that we need to take into consideration into the scope phase is the data quality. We have two main data. The primary data measures, this is parameters or measures taken directly in the field of the study, secondary data from papers, research, reports, etc. The time horizon for the LCA for a specific period of time or the average over extended period. For example, if you decide to do an LCA, you need to understand what is the data that you are going to include. In this case, for 2019, average of the life 5 years, you have to do an statistical analysis, etc. And also the audience. What is the intended audience? To whom the results of the study are intended to be communicated? Production managers, bankers, NGOs, public organizations, political researchers, institutes, etc. Assumption, for example, when the data is not available, you need and you decide to exclude a specific process such as transportation, water treatment, emission of X element, etc. The inventory analysis. Inventory refers to the consumption of energy, materials, and water within the product system. In this case, another way to see what is inventory. Inventory are the inputs and outputs into the product system. I'm going to show some tables in order to understand what is the inventory phase according with the ISO 14044. Excuse me. Input and outputs into the system, energy resources, and all consumptions are in terms of the functional unit as I explained some minutes ago. This is an example of an inventory system. We have the inputs here. Let's see what happened with. We have energy, raw material, water that are the inputs to the unit process. We have emission to air, emission to water, emission to soil, but also what are my products? What are my outputs are products, byproducts, and waste. So we have to take into consideration all the elements around the unit process. For example, this is in practice an open field crop, approach system and boundaries. For example, we have the crop management, energy, materials, and water. We have emissions, the harvest, energy and materials, emissions. We have water too, of course. And we have irrigation, energy, materials, water. We have emissions. So this is a typical application of LCA, but remember that we can use life cycle in everything that you want. In any anthropogenic activity that you work on, for example, if you are studying a city, the use of water into the city, the use of food or the food to feed the people, the use of the CO2 emissions, any element or any consumption into the city, we can do a life cycle assessment or for a specific elements into the city. For example, you need to understand what is the impact of the water treatment into the city. You can do an life cycle assessment for the water treatment, or you can do an LCA for the waste treatment, or for the waste management into the city. You can do the life cycle assessment of the transportation into the city. What is the best? What system has the best performance into the city? The transportation by car, by train, by bike, by motorcycle, whatever system you can use, you can study through the life cycle assessment methodology. And in this case, you see production, mineral fertilizer and pesticides, production, transportation, and also we have consumption and waste disposal, as I explained you before. This is always what I'm trying to work is the closed loop thinking. This is the circular economy thinking. When we have the waste and try to introduce it into the crop management, into the harvest in order to avoid waste to landfill. This is a case of for a table data is collected in a kind of table as shown in this table. You see here the unit process. You have the input for this phase. We have the output. For example, here mineral fertilizers, KNO3 kilograms, the quantity, and what is the source of this element. And also we have, for example, output CO2 emissions, waste, and also what is the reference of this for each data that we use into the LCA. Other consideration is very important to do the mass balance first, because the material and energy that goes in the system will need to be balanced with the emissions to air and the product that we as outcomes of the system. It's very important to understand that we have emissions to air, water, and soil. So the sum of inputs could be equal outputs mass plus emissions. This is another case of mass balance. If we introduce 1 kilogram of raw materials and we introduce water, air, electricity, so we have the output 1 kilogram, we have co-products, we have public waste, we have emission to air and to water. All the inputs we need to quantify all inputs that should be or must be equal to all outputs of the system unit process. If you do the thermodynamic balance, you need to balance the same quantity, the input and output. This is the thermodynamics law here, and the conservation law of the material and energy. For the impact calculation, we need to understand, we need to select the impact. I'm going to explain you what is the mid or an endpoint. The midpoint are, for example, the category that you are going to study, such as climate change, eutrophication, acidification, let's see, water depletion, fossil fuel depletion. This is midpoint impact. One midpoint impact produce one endpoint. For example, risk to health, ecosystem damage, and biodiversity preservation or damage. So it's very important that you understand what impact are you going to include into the system. You have to select the impact categories, midpoint, for example. You need to do the classification and characterization, methodology of impact calculation, and the model the system using the software. This is another way to present the impact calculation. This is the same on this. And then, as I explained you, this is the midpoint impact: climate change, eutrophication, acidification, ozone layer depletion, photochemical oxidation, abiotic depletion. According with the CIMA Pro software, it it consider 18 midpoint, and the main 3 endpoints are ecosystem damage, biodiversity loss, and human health risk. This is a kind of, again, another way to present the impact. The inventory, we have the inventory. This is the main element of, let's see, when we have a production, we have some elements that are emitted to soil, water, and air. And this is the inventory in terms of elements. These elements produce midpoint impacts such as human toxicity, radiation, climate change, ozone layer depletion, and then we have the endpoint. For example, climate change affect the damage to human health, damage to human health, and damage to ecosystem biodiversity. So this is important to understand the kind of impact that we can consider into the LCA. The classification is very important. This is the thinking of the software. If you have a kind of let's see, Excel sheet, you can calculate. For example, you need to classify the different elements. For example, CO2 and CFC affect the global warming potential, but CFC affect the ozone layer depletion. NOx affects acidification and eutrophication. Ethylene CXHG family affects photochemical oxidation. Energy is cause energy depletion. So, and then when after the classification, you need to do the characterization. For example, one molecule of CO2, but this is the damage that produce one molecule of CO2 to the atmosphere. But one molecule, the CO2 represent in terms of global warming potential 3,400 damage. So what is the main conclusion of this? That we need to avoid the emission of CF11 to the air because the damage is, I don't know, 3,400 higher than the CO2 molecule. So you understand that there are 4 main elements that produce the climate change or the global warming potential: methane, nitrous N2O, oxide nitrous, CO2, CFC, perchlorofluorocarbonados. Is difficult to say the word in English. And also there are 4 main elements that produce the CO2. And also you can see here the impact factor for each element that produce several damage to the environment. So in this case, you see, this is the global warming potential, ozone layer depletion, acidification potential, photochemical oxidation formation, and some others. So this is a case of the most important thing here is the impact or the, let's see, the footprint will be the emission per impact factor. This is the equivalent impact. The sum of the emissions per the impact factor produce the footprint or the impact. That is the main important parameter that we can have from one LCA, but it's too huge when we have one product because there are several impacts, several categories, several impact factors, and in order to get this information, we need to study in deep the system to have a robust LCA, a robust LCA. In this case, this is an example of characterization when we can calculate, for example, the global warming potential. This is the characterization, 50 per 1 kilogram of CO2. In this case, 0.5 per 3,400. This is the carbon footprint or the global warming potential. This is one outcome of the LCA, and also we have here the LCA ozone layer depletion, the acidification, the eutrophisation, the photochemical oxidation formation, and this is a kind of information that we can have from one LCA, as we will see in the example. To calculate the impact assessment, we have several methodologies as CMLA 2000, Eco Indicator, Recipe 2016, Midpoint Hierarchy, others. What is the difference between different methodologies? Is minimum. We can observe some differences between the climate change calculated with CML and Recipe 2016. There are some different in decimals in the final number for climate change, for example, but it could be the same, but there are a little bit different. But for example, the eco indicator has another categories that are not included in the Recipe 2016. But the most used in my case, when I practice the LCA, I use the Recipe 2016. I think there are updated recipe methodology, I think Recipe 2018 or something like that. Another important issue is to understand that there are different software to calculate the impact. When we modulate, in this case, we have, I use the Sigma Pro. This is a good news for FARA. Right now, our university, both the Sigma Pro version 9.0 and the EcoInvent database in order to do for a student to learn how to use the Sigma Pro and to calculate and to do LCA in practice, because it was very hard for us to have the Sigma Pro because it's an expensive software, and not exactly too expensive. The most important thing is that some other careers in the University of Costa Rica, such as mechanical engineer, electrical engineer, civil engineer, chemical engineer, biosystems, agricultural, and other schools or faculties, is very important to have the Sigma Pro in our university, especially in industrial engineering, where I work. The interpretation is another important issue. Let's see. Interpretation means to correlate the inventory data into the different phases of the life cycle to understand what are the main contributors of the impacts into the different stages. For example, let's see, we have the inventory, the use of energy, water, and resources produce impacts, which has that we can compilate into the inventory data, and we have the impact. So when we finish the LCA, after modulate the impacts, we can identify the main contributors, the changes in the process, and we can do many things. Sensitivity analysis is very important. As I explained you, the LCA permits to understand which technology is the best, which is the best waste management in order to control or to mitigate the impacts that are produced by the waste management. For example, if you have this pencil here, blackboard pencil, if you reduce the plastic here in millions of this pencil, what is the impact avoided to the environment? You can calculate this only with the LCA. And also you can use the LCA to do an eco design, for example. For a new technology, eco design, let's see, is a robust tool for you and for the people that want to know what is the impact of a process or system to the environment. Here's I have some examples. What is the lowest impact packaging to bring sandwich, for example, for 1 year? Reusable in this case, because you use, for example, when you go to the university, you use you had a kind of chamber plus where you put your sandwich, and then after you go to when you get to home, you clean the recipe where you put the sandwich, the plastic, and here you can see that the aluminum is a high energy consumption. So this is the highest contributor to the impact to the environment. So let's see, in terms of CO2 emissions, this is the biggest or the highest contributor to the climate change category. In this case, which paper is the highest contributor? For example, you have here virgin paper and recycled paper. Of course, recycled paper, you are introducing for virgin paper, you have to cut the tree, you have to process, you have to transport, you have a complicated system in order to produce paper from virgin source. But when you recycling, you just collect the paper and introduce to the mill to produce again recycled paper. So it's clear.
Roberto,
and also, yes, 1 hour?
Yeah, 1 hour. We have
okay, I'm going to finish this and do a break of 5 minutes.
Sure.
In this case, we have two laptops, two computers, the laptop and the desk. Probably the desk consume more energy when this is connected outlet to the electricity source. So which is the better? This is another kind of outcome from the LCA. We have the different categories here, comparing, let's see, utility wind offshore versus a small scale wind. You see here the electricity, the LCA give us a picture of the LCA in order to take decisions. Is related to LCA, the ISO. There are several, let's see, ISO rules or standards in order to do an LCA. For example, we had the 1444 guideline for LCA, 1446 for water footprint, 1466 for carbon footprint, 1425 LCA environmental product declaration, and so on. This is some outcomes. We can do many things with the life cycle. If you don't have life cycle, for example, you can do an eco label. You need to do an environmental life cycle assessment in order to have an eco label. I think in Malaysia there are several eco labels, especially for the type 3, that we need environmental declarations, but you need to have the LCA. So it's important to understand the learning lesson from LCA. What is an LCA? What are the main steps to do an LCA? Why an LCA is used for? This is the main question or main thinkings of the lecture. To understand the relevance of LCA methodology, what do you apply this methodology in cities, factories, schools, and business? This is a picture that a huge LCA that I did here in Central America from Guatemala and Costa Rica in order to compare Guatemala and Costa Rica for the production of vegetables and fruits from the extraction to the schools in order to understand safety food for children. We study some vegetables as onions, tomatoes, pineapple, orange, and bananas, and we compare what was the basis, the higher or the best performance system through using the LCA methodology. Thank you very much for your attention. We have just one world in the universe. We take care of it. Farah, we can take 5 minutes in order to
5-minute
rest.
break for you as well.
Okay, what time is it right now in Malaysia?
12:21 in the afternoon.
Okay, yes.
And
here is
Costa Rica?
10:21. In Costa
Okay.
Rica is 10 p.m. 21.
Right.
Just 5 minutes. We will see here in 10 20 26.
26. Yeah, 26.
Yeah.
Sure.
That it will be 12:26 in
Great.
Malaysia. Okay.
Yeah,
Just a break. I'm going to drink a water.
sure.
To understand not only the LCA, I am working hard in a circular thinking, in a circular approach, in order to reintroduce the materials, the byproducts, the waste into the system. So this is a paper that I published last year regarding environmental assessment of two irrigation systems in an organic tomato crop system and in manure compost fertilization, a sustainable circular economy approach in Spain, Catalonia. It was published in Circular Economy and Sustainable magazine. Let's see.
This was your PhD study, Roberto?
Yes, I did this with Pera Muñoz.
Oh, Pera Muñoz.
Anthony Halo is an expert that is expert in circular economy and life cycle assessment. He worked in Queensland, Australia. Do you know?
Yeah, Queensland.
Yes, I would like to go there, but it's too long from here.
Yeah, it's closer from here.
Yes, more than yes. Okay, according to the circular economy action plan adopted by the European Commission, this is a background of the paper. The value of product, material, and resources is maintained in the economy for as long as possible, and the generation of waste minimized to develop a sustainable, low-carbon, resource-efficient, and competitive economy. This is an economy statement or declaration from the Circular Economy Commission in the European Commission. I'm going a little bit to talk an introduction, material and methods, results and conclusions. In this case, we have a circular economy approach was used to transform a linear model into a circular one by introducing waste into the economy system. Let's see, we have the manure from the cows, livestock, and we use this manure to transform, to produce organic fertilizers to apply into the crops. So it has very interesting results in this paper. Compost was produced from livestock manure life cycle was used to calculate the impacts related to the production system. So the research focused on the two main impacts: water depletion and climate change. Chemical fertilizer increase the yield of crops, but they are great pollutants, contributors to the environment. When you apply chemical fertilizers or mineral fertilizers, during the life cycle, production of mineral fertilizer or chemical fertilizers, they are huge emission to the environment. And then when you apply to the crop, there are emission post applications that produce several impacts, as I explained you, for some categories such as climate change, eutrophication, acidification, ecotoxicity, water depletion, etc. No, water depletion is not related to chemical fertilizer. The main source of organic fertilizers are composed from livestock manures, plant residues, and industrial waste. Livestock manure in Catalonia, Spain, is about 19 million tons per year. It's a huge quantity, which is equivalent to more than 100 million kilograms of nitrogen. If we don't use this nitrogen to produce mineral fertilizer, what happens with this? It degrades, but the microorganisms and produce several impacts. So we need to do a sustainable management of this manure in order to produce a product that can be useful for crops. In this case, organic fertilizer. Manure is a livestock residue that has little commercial value and is responsible for the environmental impact of several categories. That kind of situation happen around the world in many countries, that they don't use the manure to produce a second product. So that is a thinking of the circular economy, to use the manure to produce a kind of fertilizer in order to introduce to the system. But also in this case, I not only calculate the impact over the environment of the mineral fertilizer and the manure, but also we calculate a circular economy indicator. The objective of the research is the environmental assessment of two irrigation systems, integrated and dripping. I'm going to show you a picture what is integrated and what is dripping. For a tomato crop fertilized with a kind of compost from cattle manure, considering relevant aspects related to LCA with a circular economy approach. In this case, we can see the two approaches. The approaches for Helen MacArthur Foundation of Circular Economy, because we study the biological nutrients and also the life cycle assessment to calculate the impacts according with the ISO 1444 methodology in order to calculate the impact for the according with the LCA phases. So in this case, we can see the LCA. Let's see. I'm going to explain. Okay, let's see. We have the feed right here. This is the grass. This is the manure produced by the livestock. We have the collation, transportation, and production manure from compost. And then we apply this in tomato crop to produce tomatoes. But the waste produced in every stage or after consumption, mainly, we introduce this into the system as a mineral, as a organic fertilizer in order to fertilize the grass. So this is very interesting, a cycle. You see, This is a closed loop cycle. This is the circular economy thinking. But the interesting things, not only the extraction, but also we have emission to air in each stage of the life cycle. The manure was applied for the most consumed and traditional tomato variety, the comparison esculentum bar puncha, for two integration systems, dripping and integrated. And here the tomatoes. Okay, as I explained you, the 8 elements of the LCA hold quantify environmental impact of a crop tomato system, fusion, in this case for the compost from livestock manure to fertilize a tomato crop. This is the function of the compost of the, or another name is organic fertilizer or compost. Functional unit, 1 kilogram of tomato fertilized with compost production from livestock manure. Boundaries cradle to cradle, because I use the thinking from the production of the manure through all stages, and then produce the tomatoes, apply the compost to fertilize tomato as here, and then the waste produced during the consumption and the different stages we introduce into the system. This is a cycle. Boundaries, cradle to cradle, cultivation, transportation, compost production, and harvesting. Audience, farmers, LCI practitioners, scientific, academic. Period time, 1 crop of tomato between 2015 and 2016. Data source, primary data, the question that I asked for. Data for inventory, secondary data, emission from compost production. Good criteria. This is a criteria in order to avoid impacts that are not very important. We exclude some impacts that did not represent more than 3% of the impact of the total impacts. This is another way to represent the system diagram. We have the production of compost, we have transport of compost, transport of seeds, nursery, and then we use this is the cultivation and harvesting, the different phases. In this case, the experiment was developed on an organic farm located in Vilanova, La Quila, in Catalonia, where Farah lived for 2 years, or for 1 year. The farm where the crop was developed on an station on 360 square meters. The tomato plants were grown with a separation of 0.9 meters and a separation 1.2 meters between rows. This is the one plant, another plant. The separation was of 0.9 meters, but there are some lines, rows, and they was separated 1.2 meters. And the density of plant was 0.92 plants per square meter. This is the experimental plot, as you see here. Very interesting. It's a real case. And also, I invented, in this case, a material circularity indicator. I guess this is a yield productivity indicator, but I call this as a material circularity. This is the, okay, let's see. And then I'm going to explain. We are trying to avoid waste to landfill. And we produce, we have, for example, our functional unit, 1 ton of manure. How many tons of organic compost was produced for 1 ton of manure? This is the indicator, as I show you, as I will show you later. In this case, we have the results. For example, we can see here the production of tomatoes, the yield kilogram per square meter. In this case, we had that the integrated has a higher production comparing 2015 versus 2014. As you see here, it was the rate was higher for integrated. But let's see what's happened here between one year to another. Let's see. In this case, we can see that the tomato, integrated tomato versus dripping in the 2014 was higher for dripping. In this case, in the 2015, the integrated system was higher. Why? One interesting issue or situation happened in 2015. In 2015, rate was higher in 2015 than 2014. So integrated system was more, let's see, what is the word in this? I'm not sure. Was more sensible. I don't know how to say that in English really. So, or the water affected in positive results, they integrated because we have a higher quantity. But in regards with the dripping, compared the rate between dripping and integrated for each year, we noted a randomly behavior in the two systems per year. So it was very interesting results that we had to analyze in depth in order to have some conclusions. But just to understand what's happening here, it's important to understand what is the total yield and the commercial yield, but it's more important to understand this. So in terms of environmental impact per category, we decided to choose just 1, 2, 3, 4, 5, 6, 7, 8, those 7 categories: climate change, ozone-layer depletion, terrestrial acidification, freshwater eutrophication, water depletion. And you can see here that all categories, the integrated system has better environmental performance, except in water depletion. Why in water depletion? Because integrated, that this system consume more water per functional unit. That is the main explanation of why water depletion was higher integrated than dripping, And the all categories, except water depletion, integrated system has the best environmental performance. For the two categories that we take into consideration, mainly the climate change, we can see here another outcome of the LCA. Protection structure and mulching. This is mainly made by steel. Okay, for both systems, protection structure and mulching has the highest impact into the system and compost production. This is the analysis, the main contributors per stage. But in water, just one category, of course, irrigation was the higher impact compared with the protection structure, mulching, and machinery, because irrigation is the water applied to the crop. It's logic, the result. So regarding the circular indicator, we can see that we produce 685 kilograms of fertilizer per 1 ton of manure. That represents 68% 68.5%. That means a high circularity index. If we compare with the 50, with the middle, with the 50%. Yes, circularity index is one approach to waste of waste to economy, circular economy. Sorry, it's a kind of let's see productivity, and I use the productivity or yield as circularity indicator for the system. As you see, so it's very important not only to calculate the impact, but also the contributions of the manure or the fertilizer, that this is generally a way that goes to landfill or lixiviate to the groundwater and cause several impacts on the environment. This is very important thinking, because we are considering not only the LCA, but also the circularity indicator. Conclusions. Agrarian water supply contributed to higher yield fruit for the two irrigation systems. Integrated system showed a better environmental performance than the dripping system in all category assessed. The higher yield observed was for the dripping system. For the dripping system has the high yield. A circularity indicator of 60% more or less. 60% more or less. Organic fertilizer from the compost process per total mass of manure was produced. It's an excellent indicator. And this is the presentation of the case study that we publish directly into the journal. Thank you very much. If you have any question, you are welcome. I am here to hear your comment, or if you have any question. I'm sorry for my English. I am trying to do the best.
Okay. Very interesting study. Okay, any question from the students?
Okay.
Anyone?
Any question?
Maybe I can start first. They will follow up later. Roberto, the two methods just now, integrated and dripping. So the dripping one, what is the method used? Is it that they just let the water drip on the soil?
Yes, this is, you have the plant here, and drip water for the plant directly. An integrated system, you have, let's see, I don't know how can I say that. A kind of cane, yes, spread the water over there. So I think it's more efficient. It depends on the dripping, because this is over the, yes. But in 2014, the rain was lower than 2015. The integrated system reflects or absorbs more water than the dripping, because it has water for all the crop.
I see.
So it was better. I think it was very interesting result.
Yeah.
I think there are a kind of technical issues around the crop that are difficult to explain, but in general, that was the situation.
So are you able to say which one is better in absolute, or is it just we provide them some information, some knowledge, which one is applicable for maybe for rainy season? We can use integrated system.
That's okay. And also remember that it's very important that LCA depend on the geography, the data, and the year, because the problem that we have right now in the society is a complex, because the system's behavior is totally different in Spain, in Malaysia, in Costa Rica, in the United States, because it depends on the weather, the crop management, and the soil, the complex of the society is not easy, because for that reason, when you practice the LCA, you need to have a clear information, and also you have to you need to study what are your scope, what are your system boundaries, in order to have real comparisons in practice, because it's not easy to have a good results. You need to understand what is my scope, what is my system boundary, what is my boundaries, etc.
Yeah. Sabrina, would you like to ask your question just now? The one on the data.
Yes. So I would like to know about the data. Does the LCA only require long-term data, or it can also be applied for short-term data?
Excellent question, Sabrina. Muchas gracias. Muchas gracias in Spanish. It means thank you very much.
Thank you very much. Yeah.
Very interesting question. Let's see. I think the horizon of time, it depends on the data that you have, because the LCA is very expensive study, and also you have the data only for one crop, for one cycle in this case. But if you are in a factory, for example, if you have the data of 1, 2, or 5 years, I think it's better, because you can do an statistics analysis of the information. But at least 1 year, I think. You can do that for sure. I think for 6 months, 1 year. I think 1 year is okay. But if you have more data, I think it's better, because you can understand what is you can do the statistic analysis in order to understand what is the behavior of the data in time. Maybe you know so much about this, what kind of distribution of the data and things like that.
Okay, Roberto. Thank you.
Thank you, Sabrina. Anyone else would like to ask questions?
Hi, Roberto.
Hi.
Sorry, I'm looking for association. As you said on the first presentation about the importance of data collection in LCA. In relation to the second presentation of yours, is it true that the data we collect from the second presentation from the CE is the integrated enripping method punya data? So the result is the height circular index. Is it true the data collection used in good performance for high quality result?
Yeah. I think in this case, we have two kinds of data. The primary data, in this case, because we have the activity data. For example, we have 1 ton of manure, and we did the transformation of the manure to produce compost. We have this is a primary data, because we weight the manure and we weight the organic fertilizer, and we have an indicator. But in some cases, we don't have the data. So what we did, what we can do if we don't have the data, we need to go to the paper. I don't know if I am answering the question, Farah.
I think you are answering the question.
Okay.
Just on quality
In this case, for example, if, when you modulate LCA, you need, for example, what is the process to produce the steel, the bar for steel, to support the plant or the tomato. So, but we don't know, we don't have the data the primary data because we cannot. It's not important in this case. It's important, but it's not the focus of the study because we have a process in Sigma Pro in EquiInvent database where we take the process to produce the steel to support the bars to support the plant. So because we don't know, for example, what is the emission of the nitrogen apply into the for the crop? If we don't have the data, because we don't have the methane equipment in order to know what is the emission per 1 kilogram of nitrogen or mineral fertilizer or organic fertilizer. So we can go to technical literature or paper in order to have what is the data of emissions. But in some cases, if we have the equipment, if we have the money, if we have the resources, if we can do, but in sometimes it's very difficult to have the primary data. We have the primary data for the activity. For example, if you are producing bottled water, you have which is the production, you have the electricity consumption, you have the for the lift, the car lift to rise the weight, and also you have the diesel consumed at plant, etc. But you don't have what is the emission, for example, the impact factor when you burn 1 liter of diesel or gasoline or something like that. So you need to go to Malaysian department that has the emission data from scientifics that you know what I mean, yeah.
Yeah.
If you don't have data, you
We call
need
it
to go
foreground data, Roberto, like foreground data. Data before you get that material. Yeah, I
No,
understand.
it's not. Yeah, an LCA is not easy. It is easy, but you need to be concentrated. You need to study the system.
Yeah.
Right now, as I would like to do you have the Sigma Pro right now, Farah?
No. We have returned the laptop to the university the other time. So yeah, we don't have Sima Pro now. Are you going to show something? Or
Okay.
because it's very expensive, so we didn't get to buy
Okay,
it.
we buy a one license for 1 year. This is, let me show you something. I don't know if we finish right now or
Yeah, we finished. So this is more to sharing. Yeah. If the student have
I
questions,
think
you can
the
ask.
class finish.
Yeah, the class finish.
Yeah. I don't know if you have more questions or everything is okay or.
You have any more questions, students? No more? Okay, if you can maybe take one group photo, Roberto.
Okay.
Let me just share the.
You're welcome, Nur Nabila.
Okay, let me open the. Can you all turn on your camera?
Put your camera, please.
Yeah, Roberto would like to see everyone.
Yes, I would like to see. Let's see. Okay.
Okay, everyone. Farah Azahira, we can see your background, but you're not there. I want to open the poster, but I don't know why it's not coming out. Wait, Sabrina, can you help me with the poster? If you can share the poster on the screen. Sabrina prepared the poster, Roberto, so it's very nice. Let me check. What is it, Sabrina? I don't know why it's not coming. Okay, here it is. Okay. All right. Can you see that? Okay. Right, everybody, let's pause. Sabrina, you can count and take the photo.
Okay, all right. So everyone can like smile. Okay, 1, 2, 3. One more time. 1, 2, 3. Okay.
Right. So we have come to the end of our session. Thank you so much, Roberto, for your
You're
very
welcome.
insightful presentation. I hope the student gain some information. Maybe you find it a little bit complicated for you, but it's good enough if you can understand the concept, to
Yeah.
describe some of the components. Okay, because like Roberto said, this is we did this for our PhD and some of us for our masters. So it's uh, I know that it's a very high level for you all as well at this moment. So it's already good if you can get the concept, right,
Okay,
Roberto?
that's okay. Yeah, that's right. Let me explain you something. I also teach this environmental engineering for industrial engineering.
Industrial engineering.
So yes, I just give the concepts like this. This is the same presentation for our students, just to know the concepts. What is the importance of LCA? What are the inventory? What is important? Yes, it's the same.
Get some
situation,
overview. Yeah.
Yeah, but it could be very important for you if you can look for the software and give a not complicated exercise.
Yeah.
But at least one exercise in order if someone get motivated to do an LCA, I think it's possible. They are in capacity to do that, no problem.
I see that CIMA Pro has the what do you call it, that student version. So I was checking it, and I think we can do like one tutorial. Maybe I can do with them later on, and just to get them some exposure on LCA, what it is about. Last week we did material flow analysis. We used STAN, the substance flow analysis. I think that was developed by a group of academics from Denmark. It was quite good. So
very interesting.
we can explore LCA after this as well.
Yeah.
So thank you so much, Roberto, for your time. I mean, it's already night over there. And it's good to catch up with you as well. Good time. I want to show you one good photo I found just now.
Yeah.
It's like
maybe next year, or I don't know. We can come here to Costa Rica. You can come here.
I would like to. Oh my God, Costa Rica must be really nice.
Yes, it will
And
be.
Roberto, tell us one thing about Costa Rica. We want to learn something about Costa Rica.
Do you want to know something about Costa Rica?
Yeah.
Okay, Costa Rica is a small country.
Okay.
5 million people. How many people are you in Malaysia?
Almost 30 million.
Oh, really? Okay,
Yeah,
5 million
28,
people.
29, yeah.
Our main activity is cultivation of crops. It's okay, crops.
Wow, all right.
No, we have let's see, a pineapple. Okay, banana, and also we have a very clean energy. 100% of electricity come from hydropower, geothermic, wind.
Wow, interesting.
Okay.
100%.
Very interesting. 98%.
98%.
But
Wow,
electricity.
amazing.
But we use, of course, fuel for transportation.
Of course, yeah.
Right now, but we are now we are doing changes in the economy in order to introduce electric cars.
Electric cars, yeah.
Maybe Malaysia too.
Yeah, here as well.
Well,
They're giving tax relief and tax exemption for electrical vehicles and also hybrid cars. So good move. We're moving, but a little bit slower perhaps.
Okay, and also Costa Rica, well, is located in Central America between, I don't know, maybe for you it's very complicated, Nicaragua and Panama, the two countries, or close to Colombia, a little bit close to Brazil, not so much. That's
Okay.
it's 5 hours from Brazil or 3 hours from Mexico
Okay.
City. From Miami, 2 hours and 45 minutes by plane.
Wow. And to New York? You went to New York you teach in New York as well?
Yes, I've been in New York for 1 semester teaching at the Urban Sustainability Master. What is about Costa Rica? I think we are a developing country.
Yeah, the same.
But yes, no, but Malaysia, I think, is almost developed.
almost. Yeah.
No, but, and also, I don't know, we practice exports. The religious is Catholic. This is from Spain mainly. We speak Spanish, but also young people right now, many people here are bilingual.
Wow, good.
Yeah. What else? We have 4 main universities, public universities, and many private universities. It's too expensive.
Right.
What else?
So, Universidad de Costa Rica is one of the 4?
Yes, one of the 4.
Right.
Instituto Tecnológico de Costa Rica y Universidad Nacional.
I see. Okay.
Yeah, very interesting. What else? I have a friend. I have a friend that was in Malaysia last year in Cambodia, Malaysia, Vietnam,
yeah, Cambodia, yeah.
Malaysia, and Japan.
Wow.
He was very impressed about
in Malaysia.
About Malaysia, yes.
Wow, you should come also, Roberto, please.
The tower.
Oh, the tower, of course.
Petronas.
The Petronas. Yeah.
You are close from Petronas?
It's like 1 hour from our campus. 1 hour.
Really?
Yeah.
By train or by metro?
By car. By train it would take little bit longer because we don't have a close connection there. Yeah. So like Puncak Alam, our campus is a little bit in the suburban area. So like 1 hour by car, more or less.
Yeah. And our country is focusing on sustainability. Is part of our. We work hard on this matter.
Of course.
What else?
Great
nice
sharing.
country, mountain lakes, and
mountain. Wow.
To see Pacific and Atlantic. It's a nice. I think it's similar than
beautiful beaches.
Many beaches, yeah, lakes, and volcanoes.
Las
Maybe
Playas.
Malaysia.
Yeah, we do have lakes. We have beaches as well. We have the rainforest, the eco rainforest. Really? Yeah, lovely.
We have 53% of the territory has let's see, green cover.
Right.
Yeah.
Yeah.
And 25% of the territory is protected by law.
Wow.
We cannot cut trees here.
Good.
There are interesting things, but we are very, very long to be sustainable.
Right. It's okay.
But we are trying to do the best here.
Yeah, of course. I found
if you want to come to Costa Rica, you can go here. Rasik, Ifaf, Sabrina, Nilaf.
Yeah. Hopefully we can all go there. Maybe after they start working and maybe they want to venture into industrial ecology. Who knows? And you find your passion and travel.
Yeah. You rent a plane and come with all of your students here to Costa Rica. You are welcome. Yeah.
This is an old photo, Roberto. Do you see? Look how young we were.
Oh my God.
Yeah, this is during the La Casa Sultana. In the park.
Yes.
Yeah.
I've been in touch with I've been in touch with Tito Morales.
Oh, really? How
I
is
have been in
he?
touch
I
with,
miss
yeah.
Tito. Oh my God.
He is a nice person, yeah.
He's in Chile, right?
Yeah, he's an outstanding person too.
Oh,
I've been
really?
working. Yes, I've been working with Tito Morales in some thesis.
Ah, I see. I see.
I
And that's
suppose
Jordi, right? No, not Jordi.
Jordi, see, yes, Jordi.
Yeah, Jordi. Yeah. Well, good
I think.
time. Good time. So
Yes.
thank you so much, Roberto, and I hope the students gain something. Sabrina, would you like to say anything to Roberto on behalf of everyone?
I would like to say it was a good sharing session from Roberto. We got like a lot of information on LCA itself. Hopefully, like we can use all the information to apply in our studies after this with Dr. Farah. So thank you very much,
Okay.
Roberto.
Thank
Thank you
you.
so
Thank you for you.
much.
Good night and
And
have a good day.
good night. You too. Have a good night. Thank you for your
Yeah.
time. And
Enjoy
we'll
the
keep in
life and
Yeah.
beautiful, and God protect you. Bye bye.
Bye-bye.
Bye. Thank you, Roberto.
Adios. Thank you,
Bye bye.
Roberto.
Thank you,
Bye
Roberto.
bye.